video is on Unit 6, Chapter 12, Exponential and Log Functions, Lesson number 6, Review. So in this video, all I'm going to do is review all of the different methods of solving logarithmic and exponential functions. This is not a review of lesson number 1 and lesson number 2 because we actually use those skills as we solve our logarithmic and exponential functions. So looking at example number 1 and 2 and 3 and 4, what I notice about these 4 problems is that we have logs on both sides. So the rule for solving equations where you have logs on both sides is to drop your logs and solve the equation. But you have to make sure you have one log equals one log. So number 1 and number 2 are good, but number 3's got too many logs and number 4's got too many logs. So we would have to condense before we can drop. Make sure that you've got that. You have to make sure that you have one log on the left equals one log on the right before you drop your logs and solve the resulting equations. So number 1, really quick and easy, we're going to get rid of those logs and set up our 9x minus 4 equals the x plus 20. Subtract your x, add the 4, and we get x equals 3. Also, as long as you've got somewhere in the equation log, you have to check your solutions to make sure that you don't have any extraneous solutions. So this is one that I would have to check because it started out saying log. When you plug in the 3, just to save time in this video, I will tell you that it does work. 3 does work. Number 2 is the same. Drop the logs and solve. You should, I'm not going to work out every single one of these, but what you should get, this is a quadratic, you should get m equals 4 and m equals negative 3. And what you'll find out is that the negative 3 won't work. It's an extraneous solution. So for number 2, you should just get m equals 4. On number 4, I'm going to jump to number 4. I've got log of 2i minus 7 is equal to 7 times log of 2 minus log of 8. So 7 right now represents a product, but with logs, it's an exponent. So I'm going to get rid of that 7 first. So I've condensed that part. And then through division, because there's a minus here, I can combine both logs on the right to just one log. So I need 2 to the 7th power divided by 8. So that's going to make that one log. So 2 to the 7th power is 128. And then when I divide that by 8, I get 16. So the right side now says log of 16. The left side is log of 2i minus 10. And now we can drop those logs and solve the equation. I'm going to add the 10 and divide by the 2 and get 13. Plug that back into the original equation and it will work. Number 3 is the same. Don't forget to condense on the left. What you should get on number 3 is a equals 9. All right, so now let's jump down to numbers 5 and 6, 7, and 8. What I first noticed about these 4 is that the right side of every single equation doesn't say log. So I have a log on one side. Your rule here, your strategy is going to be to change this back to an exponential form. But you have to make sure, once again, that that log, the side that has the log, is just one log. So number 8, we're going to have to condense before we move, before we change it. Let's look at number 6. Number 6, I've got log base 36 of 20 minus 4p is equal to 1/2. So this is ready for me to set it up in exponent form. The base of the log is the base on my exponent. The answer to the log is my exponent is equal to the 20 minus 4b. 36 to the 1/2 power is the same thing as the square root of 36, which is 6. I'm going to subtract the 20. 6 minus 20 is negative 14. And then I divide by the negative 4, and I get 7/2. Again, we have a log in our equation, so you have to check those solutions, and it will check out. I want to jump down to number 8. Number 8 says log of n plus 8 plus log of 4 is equal to 2. So before I can change this to exponential form, I need to condense the left side. And because there's a plus in the middle, we're going to multiply that n plus 8 times 4. Log of 4n plus 32 equals the 2. And now we can change it. So the base on this log, it's a common log, is 10. And 10 squared is 100. Subtract your 32. And you get 68. And then divide by the 4. And you get 17. Again, plug that back in. Because there's a log in your equation, you have to check your solution. And once you check it, it'll check out. It works. Let me back up. I want to go ahead and tell you that on number 5, you need to work this out. You should get n equals 11. And on number 7, you should get k equals 31. For extra practice, I would encourage you to work out every single one of these that I'm not working. All right, so exponential equations is what we have on the next page here. With exponential equations, it's all about same base. Can I get the same base? If not, what do I do? So number 9 and number 10 are going to be examples of same base. When I look at number 9, I see 5s. That they both end in a 5, which tells me I should be able to write both of them as a power of 5. 25 is going to be 5 squared. 625 is 5 to the 4th power. So then I'm going to write that, replace the 25 with the 5 squared, replace the 625 with 5 to the 4th, and then I can drop those bases, and I have 2v minus 4 equals 4. And remember, it's because you have to multiply or distribute that. Add the 4 and divide by 2, and we get v equals 4. Now, this one, in this equation, nothing said log, so I don't have to check these. You can check them if you want, but you don't have to. No extraneous solutions here. Number 10, 2 is going to be your base. I want you to practice with this. And your answer for number 10 should be x equals 1/6. Let's jump down to this next set. So for the rest of these, the next 6, there's no way to get the same base. What you have to do is isolate the exponential part and solve. I'm going to skip number 11 and number 12 because you just need to change those to log form and solve. So I'm going to tell you that this one's k equals 2.095. Again, you are changing these to logs, so make sure you check your solutions. And this one is m equals 7.983. I want to look at 13 and 14. They're very similar. I'm going to work number 14. 14 to the 3 minus 8x plus 9 is equal to 77. So 14 to the 3 minus 8x is your exponent part. And I need to get it by itself, so I'm going to subtract the 9. $77 minus 9 is going to be 68. Then I can change it to a log. Log base 14 of 68 is 3 minus 8x. We're going to go ahead and calculate that log base 14 of 68 and get 1.599. Then subtract the 3, negative 1.401, and then divide by the negative 8, 0.175. And the answer to number 13 is 0.504. And it's very similar to number 14. And then for 15 and 16, let me work number 15. Again, you've got to make sure that you're getting your exponential part by itself. So I'm going to add 21 first. 51 plus 21 is going to be 72. You need to divide by the 8. 72 divided by 8 is 9. And then we can change this to a log. Log base 3 of 9 should be equal to 2. And add the 1, and we get n equals 3. You do need to check that. You've got a log in there, so please make sure that you're checking that, and it should work. Number 16 is the same type of equation. I can tell you that the final answer is R equals 0.425. So those are your notes for lesson number 6 on the review.